So hi everyone, thank you for joining. My name is Hichem and I'll try to use open source to solve real life problems. Not all of them, but at least one that we can take here to prove the purpose and the usage of open source. So this disclaimer here, there's no contribution to any open source project. We rate some, by using open source, you will discover a lot of things. So raise some issues and hopefully we can contribute to some of these Jira tickets that we open, but there is no direct contribution. My vision of things, what I'm presenting here is biased, but it doesn't mean I'm stubborn. So if you have any recommendation, if you think there was something missing or something that can help, please shout at me. This work here is based on the principle of open source, obviously, but it's also on open data, knowledge sharing, research papers. So it's like a broader sharing and open source stuff, and human learning, most importantly, is a lifelong work in progress. So I'm open source product architect at Instaclustr by NetApp, and I'll tell you a second what we do. And coming from a different background, so I was an end user, and then I'm building product, then going back to and implementing project and building platforms. So I'm speaking as a practitioner, at least today. So what we do at Instaclustr, we provide a SaaS platform with different open source product. We have a set of experts, but we also want to enable people to become more and more open source driven and participating. We give back to the community. We have commuters here, contributors to some of this product. Okay, so this is the agenda here that I will definitely not follow. What's the first thing here? So what are the fundamentals, just quickly, of real-time machine learning? Maybe it's like a new field. I just want to remove all the cryptic, like the complicated, obscure meaning. And the reason is just to show you that, if we understand this word, as software engineers or platform engineers or contributor, we can also help and shape these new things in machine learning. So this is like encourage you to embrace or try to get an idea of what's happening there, because we have a role to play in this stuff. And by removing all the trendy and complex stuff, we can definitely get there. So another title would be for this talk would be definitely like, how to treat post-COVID and pandemic fatigue, burnout, and depression by cycling, like, cycling to the office, cycling to buy grocery, taking kids to school. So after the COVID, kind of, embrace this completely, and you all know where I live, in the suburbs of Paris. You are welcome to come and take a coffee in my neighborhood. And so, like, every morning is just like a simple question: how do I get from my place to the office, NetApp office on the other side of the city? So yeah, just a question like, what is the fastest cycle route? Then you get stuck in the traffic. The Parisian traffic is horrible, and the Parisian also are horrible. And then you get there, and and you say, whoa, is there a way to avoid all this? And then you are kind of, cycling, and talking about depression, how to solve this problem, and you start to get like, health also, like, it's the pollution, and I want to avoid all the pollution on my way. Is there a way to find a solution to this? Maybe, but the answer was not obvious. And just to get like an idea of how to solve this, you have to go to different sources, air quality, traffic, different things. And this is at this point just static. It gives you an idea right now, but you don't know what's happening. And you can see, like, I'll show you later on that took me like 55 minutes in average to get from point A to B. So I said, maybe there is a solution out there, and I went to the main tool that all of us we use, but I said here, the best solution so far. So I'm not bashing or doing anything, I'm just hiding names here. So this is the best solution we have so far, and I said, yeah, this is maybe the right answer. So you end up in parking lots, of course, accidents, and closed roads anyway. So this was the best solution so far, but it's not the perfect, and it doesn't answer the question anyway. And if your French is not rusty there, and if you know more word than baguette, you can see that says out there that the bike routes are not always taken into account the real-time or actual conditions. So I said maybe Paris is not the right city for cycling, as you could guess. Amsterdam is the capital of cycling in Europe. And I went there and I found out that the questions were pretty the same. So how does the algorithm work? How is the shortest, and how come we go into truck roads and stuff like this? So it's like, at least in my perspective, it's a real problem after all. How do we solve the problem? There is no solution out there, so we need to build it. And since my background somehow was in academia, I said there is probably something out there, and there were some articles. There is some great work, at least to give you like an idea. Well, for I think it's German, it's air quality adjusting routing for cycling and pedestrians. And so some like Indian researchers, because I gave this talk in South Asia not long time ago in Vietnam. I think a lot of Asian academics and software and open source are really kind of taking this serious subject here, like pollution. So you can find a lot of work happening in China and in India, a lot of researchers trying to tackle this problem. But it remains kind of, in research and in academia, it doesn't give us any concrete solution so far. So in a nutshell, what do we have to do? So we need to ingest all the data that we have, put it in a box. Hopefully it's a glass box, if you know my reference here. We don't want it to be a black box. We want to understand what's happening there and give us a prediction. So the only definition here that we'll have is, so real-time machine learning is the application of machine learning to generate predictions based on what's happening now. So it can evolve, it can kind of change the prediction or the inference, name it, into what's happening and regenerate other recommendation or other routes here in this case. I'll be preaching, convince people. This is where open source, will just definitely solve this problem. And we start like thinking, yes, a lot of people involved, at least in discussion here. And this is, as an architect, we love to do design. And this is my kind of, my design, just stitching things together, and hopefully they will work. They never work together, of course. And so just to give you an idea here, and I'm no way expert in all of this. So just the key thing I added for the Fling community, I added Fling this morning. So I confess, I was scared. I was too scared of you guys. So I added Fling just to, But because, I added it also because there is a Fling operator on Kubernetes. You see small thing there. It's like, Kubernetes kind of built platform. So added Fling there. So there are different tools. The objective was open source and mainly open source. There is a level, there is degree of how open source are everything, licenses. I'm no expert and I don't want to go into this. I want to bring together all the open source that can help. So ingestion, this is quite obvious. And, like user event, real-time data, bring this together, have a model that is trained offline, then bring the features and stuff like that. I learned a lot of things, by the way, and things that I've never heard about. before, like, the feature, the online feature learning. It's a pretty cool thing when you can use Cassandra and other key store stuff. So yeah, so this is somehow like the design. So how can we put something in place to do this? And by the way, just I wanna, there's no suspense here though. There is no, I'm not spoiling you. This is still a work in progress. So stitching things together. Okay, so the challenges. Well, the challenges where it comes to this, real-time machine learning, and I have some subtitles there. Solving them requires a lot of team to come together. So Ship, she has been doing like a real great job in this field, and she has a book. I'll do some publicity for her. If you want to learn more about machine learning from a software engineering, perspective, so designing machine learning system is a really great thing. So there is two sets of, I would say, of issues or challenges. There is the one that are from data science or modeling side, and there is the other side, which are like platform or stack or technical stack side. So I'm not trying to minimize here that the work that from data science is happening. I'm just saying, in this case, let's split them into two, and there is a consensus, at least, or there is like an agreement that the major issues are, from challenges, they're from the platform side. As I showed you, it's a complex thing, and you need to stitch together a lot of things to at least get a working solution, try to approximate the solution for this. So if I go back to, as I was saying, we kind of contribute, we can, as open source software engineers, wherever we can contribute to help shape this stuff. There is no blueprint so far for real-time machine learning. There is no standard. A lot of big tech companies, they don't communicate on this. Maybe it's like a competitive advantage, but we want to solve real-life problems with our open source. So just like an example, you discuss this with a lot of machine learning or data science practitioners. They've never had to interact with the data stream or something like, streaming architecture. This is something completely new for them. So we can influence how they maybe, build solutions or models or other thing using things that we already know or kind of have experimented before. Okay, so Spark and Kubernetes, hopefully so far you all heard at least about Spark and about Kubernetes. I mean, I don't want to be biased, but for us, the best way to run Spark is to run it on Kubernetes, and you can go out there and there you can find like the pros and cons, but there are more pros and cons to run Spark and Kubernetes. And one of the key things here, if we go back to removing stuff, it's a building block to different things, stream processing, ETL and ELT, like model training. I can do, one of the reasons, especially if you're building this as a project, one of the reasons I want to remove the complexity. It's hard to remove from everything from that design, but having like a building block that can cover or can solve multiple parts of multiple bricks in this design there. So again, just quickly, why Spark and Kubernetes? Native integration with the operator. I learned how amazing sometimes, when we come to the Apache code, the community over code, I learned that there is a new operator or native operator for Spark and Kubernetes. So yeah, the best practices you have on Kubernetes will apply on Spark. We can have scalability, fault tolerance, latency. Latency, we'll discuss it a bit later, and the rich ecosystem. And in my slides before, there was cost. This is when I try to sell things, But here I have nothing to sell. I will say this is efficient infrastructure. We had discussions around our carbon footprint and other things. We want to run things, we want to solve real life problem, so they want to burn kilowatts and kilowatts of energy on this kind of things. Okay, sorry, let me turn off this. So some challenges. So we're trying to solve challenges, and if you followed already, if you're still awake, this raised other challenges after all. So we're trying to solve challenges from machine learning, and here we end up with challenges of running Spark on Kubernetes to solve other challenges. It's a bit convoluted here. Okay, one kind of, quickly see this time is flying. One of the key things here, if I can recommend, is we are just scratching the tip of the iceberg running Spark on Kubernetes. You cannot imagine how complex all the logs and logs you generate. Plus, if you already kind of use Spark, you have event driver executor logs. You have to combine them with the Kubernetes logs, and how to reconcile both. So I would say, use this, again, open source monitoring and logging frameworks and tools, and try to design this, I would say security and monitoring will be, by design. Think about your monitoring before you bring any new tool or you deploy anything into the platform. We didn't do it at the beginning, and when we tried experimenting and things went wrong, it was really kind of, obvious that we needed monitoring in place. And things like Prometheus is really amazing, because there is, by the way, a built-in Prometheus in Spark. The scalability, how did we manage this? It's not huge. If you go back to the example we're trying to solve, the data is not huge. It's just there is this variation, and there are, all this failure, because a lot of data is coming from public, sources. So you have to manage a lot of failures, changing the API without any notice, nothing. So the scalability was not an issue, but we had peaks sometimes. So I would say go back to the basics. Sorry, I went too fast on this. Cluster sizing, hardware, it's maybe common sense, but it's really kind of important to just take a moment, take a pen, and write down, what are the data sources you will be having, and how can you kind of handle this. Dynamic allocation is kind of a bit tricky here, but I will say a few words. And the shuffle, one of the issues by design there in Spark. There's a lot of shuffle happening, and it generates a lot of problems in Spark. So the right sizing, again, it's a continuous and repeated exercise. But one of the key things is go back to like the basics. And if you have a clear idea about your data sources, all of them, it's better. Because one of the key things here is to enhance the parallelism, whatever you're doing in relation to the data sources. Again, we're doing a lot of kind of streaming. And I said real time, sorry, I need to mention here, this is not kind of hardcore real time, it's near real time. Because what matters is the precision, is having a solution rather than like latency, like milliseconds, and I'll come back to this. So we will do like a lot of streaming here. One of the key things here is to keep in mind is always think about streaming as CPU bounded, but since we are doing like a stateful approach, if you don't know what is a stateful structured streaming, is that you need to keep in mind, or you need to keep track of what's happening if you want to do aggregation or drop duplicates. So you need to keep a state in place. And so since we are also kind of training some models, there is data scientists, they want to run everything on GPU. They want to burn all the GPU on Earth. So you have to go there and say, listen, there are a few things that we can maybe do a mix between CPU and GPU, and maybe even like CPU will help to do the job. So this is the part of the dynamic allocation. There is a two-sided problem. I don't know if there are a Spark expert here. So for the Spark itself, and then when Spark goes into the Kubernetes world, I have been following a ticket for the last, 6 years. So let's cross fingers. But so we have this issue, compatibility issues with dynamic allocation here, but we'll see how you do it. And shuffle data, so every time you lose an executor and you had already like did some calculation in there, you lose the data. So there is no, I mean, there are some mechanisms that we call like, PVC reuse, you're familiar with this, or graceful decommissioning, but we needed to put in place like an external shuffle solution. Again, just listed this, and let's give to César what belongs to César. There's this IBM one, which is pretty cool, and we're trying to work with IBM to kind of make it not to the upstream, but at least to maintain it and try to give it more visibility and get more traction to help with this external shuffle. Unfortunately, it works so far only in AWS, but we're trying to add the class path and work on other cloud vendors, but non on-prem. Latency, so sub-second latency expectation are a challenge. Go to Flink, to Beam. I mean, this is not like the strength of Spark, but in this case, again, we want to use a tool that help to solve different stuff. Go back to the basics again, like latency. Every programmer should know this is really important. Sometimes because now it seems like all the framework automatically do the work. No, you still have to use some skill set and knowledge. And yeah, it's the approach stateful, stateless. Again, streaming folks here will understand the subtle or not subtle the differences, and the Spark configuration. I think I need really to go quickly, even though I'm the last one, but I don't want to keep you for an hour here. Yeah, so we always have this pattern like PubSub or message bus, Kafka, Spark, Kafka to accelerate a lot of things we do. This helps a lot to reduce this latency. We use something again like Kafka, Redis, not for long. And yeah, there is something really amazing here with RocksDB that stored all the state which is in an upstream Spark, I think 3.5 or 4 already. ML training, most of ML frameworks are designed for single node environment, scikit-learn and other stuff, and Spark MLlib sadly is lagging behind. I mean, sadly, we need to contribute to this. And yeah, so there was an issue with the Torch distributor, by the way, the ticket was reopened recently. So yeah, MLlib is not enough. So I would say like, there is the Torch distributor, but works approximately right, I'd say. But there's Harvard and NVIDIA Rapids, which accelerate a lot for Spark if you use NVIDIA GPUs. But like other framework may work. It's not again the best way to train model, but again we want to reduce the complexity and not manage a zoo of solutions. This is something that is, related, and it was mentioned already, and there are folks from Apache Unicorn already. So when you do ETL, ELT on Kubernetes, Kubernetes is just a generic kind of, scheduler or manager. So in this case, if you want to go deep into things like a custom scheduling or YARN-like scheduler, you need to consider Volcano or Apache Unicorn. We went to Volcano and we are kind of pretty satisfied with it, but there's definitely a way to explore and test Apache Unicorn. Okay, so for the deployment, this is just work in progress. We don't have anything yet deployed at scale, but this is just like the thinking basic stuff. Think about your model optimization. This is for the more ML engineers and data science folks there. It's really important to think about how your model is optimized if you want to package it and serve it into an optimal way. Conclusion, yeah, use Spark, Kubernetes Spark operator, it helps a lot. Build logging and monitoring. Keep the Spark best practices, and this is really key. Use the Kubernetes kind of rich ecosystem and contribute to open source. Yes, of course, it's important to write code, but also share your experiences, applications, challenges. You have an idea, go out there and help. OpenStreetMap, which I mentioned, is like an open source mapping system. So there is local kind of branches. The French one does a lot of great work on cycling and cycle OSM and some other Java libraries. So yeah, and keep cycling. Thank you.